Okay, nothing high energy today, so let's solve one simple question. 278, first bad version. So the question is quite long. Basically, the gist of it is that just imagine that we have a versioning of our code that's a linear sequencing versioning 1 to n, and in some of the point in some version there is a bug that introduced without anyone that noticed it. It's until that in the very latest version we noticed the bug, so we want to retro and find the first version that introduced the bug. So for that purpose, we developed some kind of code method that we can call to check a version of the code. And I guess this bug checking, error checking method can be expensive, so we want to reduce the number of times that we use this thing to check our previous version of the code. So we ask it to come up with a heuristic to minimizing the number of API calls, but still be able to find the first bad version. So there's a important property of this problem is that where is it? All the versions after a bad version are also bad. So if you can imagine that when we call is bad version 1, it might return false. We call if bad version 2, it might return false. If we call is bad version 3, if it comes as 1 true, then every version after that, when we call this is bad version, it will be 1 as well. So we realize that the search space, it's actually a sorted array. So it's a 0 it begins with zeros, potentially zeros, and then everything else is 1 afterwards. So if we want to find the first one, the way we do that is to use binary search. Because a linear search, we have to do redundant work, a lot of redundant work. But if we use binary search, we can literally we can just cut the search space into half by utilizing that the property defined here. So yeah, so that's the question approach to this question. So the time complexity will be log n, and the space is constant. Let me move myself over and code this question up really quickly. So we got a load pointer, which is starting with 1, the first version, and we got a high pointer, which is n, the very last version here. While we haven't pinned down exactly which version that introduced the bug, we should check the middle one. That's the low plus high and divided by 2. If we call this method here, if it's the bad one, then we look at the left, the first half. Try to pin down exactly where this bug introduced. Otherwise, we look at the the second half. And for this case, we can actually go to m plus 1 because if m is not a bad version, then we don't need to check m in the next iteration. So that's the that's basically the code, and yeah, it looks good to me. Let's submit it. Okay, it's working and quite fast. So that's the question for today.